The new PES Wind is out, and if you haven't received it in the post, you can go to peswind.com and read it online. A bunch of great articles. This magazine is really heavy. There's a ton of articles in it. A lot of offshore discussions and technology in this particular issue. And I'm an electrical person. I'm reading the one from Bonfiglioli on the new servo motors that are made for offshore wind turbines. And when you say servo motors, I always think little tiny motors that are used in like radio control airplanes and drones and that sort of thing. But these are massive. These servo motors are used on up to 18 megawatt machines for yaw and pitch motors. But there's a lot of technology in them, a lot more than I thought, guys. When they're talking about yaw, some of the accuracy they have to have and moving these big, massive nacelles accurately is really critical.
I think the crazy thing here is that there's so many components that you don't think about within a wind turbine. Like when you talk about what Bonfiglioli is bringing to the table here, you're talking about components that we're just kind of always like, oh yeah, yaw motor, pitch motor. But when you dig into the technology of them and what really goes into them, it makes the turbine itself so much more complex, but they're doing it in a great way. So to be a supplier to an OEM like this, I think the OEMs, we have to realize they do rely on a lot of sub-suppliers all around the world to get things done. And so they turn to the experts, right? Like you want to turn to an expert for lightning protection, you call Alan Hall and myself. You want to turn to an expert for asynchronous motors and yaw and pitch drives and other things, you turn to Bonfiglioli.
And it's important too that, with how big offshore turbines are getting, that the reason that yaw and pitch needs to be so precise now is you've got the potential to have a huge rotor imbalance if you're off by even half a degree. So with, blades that are going to weigh, close to 35 tons each, and, a nacelle that probably weighs like 250 tons, if not more, at this point for these large offshore machines. Rotor imbalance is one thing. Wake effect is also another thing where you have to have a certain level of precision in the yaw motor to be able to ensure that you're directing the downflow from the turbine and the outwash from the turbine in the correct direction so that it's not impacting, another turbine that's immediately behind it or adjacent.
And the addition of a couple of sensors that they're putting onto these motors and the electrical systems to detect failures early is remarkable, because I think in the offshore case, you need to know, because there's not people going up and down those turbines every day like onshore, and getting that early detection is a huge advantage. The other thing I noticed about this, Joel, is the emphasis on weight, on reducing the weight of these servos. And my guess is offshore, if you have to replace one, the weight matters.
Yeah, big time, because just think about this when you bring the part to the turbine. You bring the part to the turbine, that transition piece has usually a davit crane, or we call it a davit crane on a vessel, but a davit crane type on the actual transition piece to get parts on. So you can't have a thing that is, 10 tons going up over there, because you're never going to be able to get it up inside the turbine unless you do have to get some crazy, offshore like lift work style lift platform or bring in a specialized vessel. You don't want to do that. So you need to be able to have everything basically maneuverable or handleable. I don't know if that's a good word, but by the technicians on the deck. And if they can't do it, then you have to bring in specialized equipment, and everything offshore gets more complicated. So when you talk about the boron and neodymium magnets, and some of those rare earth metals are heavy.
Yeah, so they're beginning to use more aluminum and lighter weight metals, plus all the environmental concerns of being offshore, where you need to add a number of features to prevent corrosion and degradation over time, which is why they're providing some of the sensors to detect that early. It's much more complicated than you think. We get used to being around 2 megawatt machines, and we see those everywhere, and the yaw and the pitch motors are pretty much ubiquitous, right? And they're swapping them out on a regular basis. You really can't do that offshore. That's where Bonfiglioli comes in and makes a really cool product. So if you haven't seen this article, you need to go to peswind.com and read it online, or reach out and get an official paper copy.